Hello everyone, in this video we will discuss how to select terms in an arithmetic progression. So what I mean by that is at times we are given questions of the form that a few numbers are in an AP and their sum equals so and so. Now we evaluate what the first number is or the second number is and so on and so forth. Now depending on how many terms there are few methods in which we can assume the AP to be, and using that kind of solves a lot of mathematical problems that appear, and like it eases down the calculation. Okay, so I'm going to show you the normal way how we can approach those problems, as well as the quick way that derives its basis from the clever selection of terms for that particular problem. So what I mean by that is the following. Okay, so let's assume that the question is of the form. We have, say, three numbers and their sum is given, say S, okay, and the three numbers are in an AP. Now the question is find the numbers, all right, and say we also have some other property of the following. We also have this, we have the product is P, okay. So what we have in this problem is the following. We are given three numbers, so A0, A1, and A2. Their product is given as P. Their sum, A0 plus A1 plus A2, is given to be S, and we know that the three numbers are in an AP. So A1 can be expressed as A0 plus D, A2 can be expressed as A0 plus 2D, and these are the four equations that are given. Now, what it comes down to is solving for the numbers. However, we have like four equations as of now, and it makes it a bit hard for us to work out A0, A1, and A2 in terms of P and S, okay? So what we do here is the following. We assume that the numbers are in the form A minus D, A, and A plus D, okay? So let's see why that works. Now, if we do this, then we note that they are in an AP. First of all, we need to ensure all the criteria are held. That is, they're in an AP. And what is the common difference here? Well, since the number from this to this increases by D, as well as the increment here, which is D as well, because if you evaluate A minus D, then that becomes D, and similarly A plus D minus A becomes D as well. So this is an AP, so it's an AP, and we can be happy about that. Now the other thing is that now that we have like used this criteria, now we need to ensure that the sum and the product is P. So why do choosing numbers of in this format as opposed to, say, a format of let's get rid of this for a while, as opposed to the format of say A plus D, and A plus 2D, right? We can also have thought of the numbers to be this. Now the thing with this sequence of three numbers is the fact that it starts from A, but the common difference here is D as well, right? So the two APs are effectively the same, but the only difference is that this AP starts from A minus D, but this AP starts from A. So it's as though if this were an infinite series, the number preceding A would have been A minus D. So it's like we have many terms in an AP, but we are considering these three terms as opposed to these three terms, where I say this term is A. Okay, so that is the only, we're basically choosing a different group of numbers in the AP. We could have started from here as well if that would have helped us, or we could have changed things in that sense. Okay, so that's the only difference we're doing, but we'd still have to show why my selection of starting with A minus D is better than, say, working with A plus D, and A plus 2D. So we're working with this, and let's see why that works out. So somebody was to ask me what the sum of this AP is, right? I would have said, well, S is the sum as it's given, and that should be equal to A minus D, A, and A plus D. All we have to do is we have to add these three numbers, like so. The nice thing that happens here is that if you notice, there's a negative D and a positive D, and both of them cancel out. So you're left with 3 times A is S. And what this gives you is that A equals S by 3. So we've effectively found out what this number is going to be. This is nothing but S by 3, the sum divided by 3. So that makes it easier, right? As opposed to, say, in this case, had we chosen A plus D, and A plus 2D, the sum in this case would have been a function of A and D as well. So we're not cancelling D, in fact, D is getting added. So we would have A 3a plus 3d. So we would have gotten a plus d equals s by 3. And in that case, our sequence, so s by 3 would have still been the middle term. So if these were the terms, we would have gotten a plus d is s by 3. And what is a plus d? Well, a plus d is the middle term, like so. And what is a here? Well, a still is the middle term, so this is still the middle term. So the idea is whatever s by 3 is always gives us the middle term. And if we have the middle term as just one variable, it helps us out a bit. Because in this case, we cannot know what the common difference is. All we know is that the middle term is a plus d, and it's function of both a and d. So if we were to figure out what the terms are, we would have to know a as well as d. However, in doing so, it turns out that we do not know a and d explicitly. We know what a plus d is, right? So even though we know the middle term in both the cases, the middle term appears to be a function of two variables in this case. However, it appears to be a variable only of one. Like, it appears a function of a variable, only one variable in this case, which makes it much better to be employed than this method, okay? So we want to reduce our load, and in that case, we ignore this method and we work with this. Now, I said this helps us with the sum. So the criteria of the sum has been dealt with. What about the criteria for the product? So we know that P is the product of the three numbers, and if the three numbers is A minus D, A plus, well, A, and A plus D, then that should be P, right? So this is what the problem statement states. Now we can employ a nice looking formula, which is A minus D, A plus D, and that gives us A square minus D square, and times A is P. Now what we can do is we can say, okay, so this can give us, well, P by A equals A square minus D square, and this gives us D square equals A square minus P by A. Okay, and taking the root on both sides, what we have is the following. So we take a root on both the sides, and we get D equals root A square minus P by A. Okay, so the thing here is that we are getting some D as a function of A as well as P. But note, we have already figured out that A is nothing but a function of S. So this formula, or this expression rather, can be written down as D equals, just substitute, eliminate A in this case. So if A equals S by 3, then A square should equal S square by 3 square, which is 9. So we can write down S square by 9 minus P by A. So that's S by 3, and the 3 comes on the top. So this becomes the formula for D. Now, if you note what I've done here is that using all the mathematics, I figured out two relations. Let me just get rid of this, as it's just cluttering things. So what we have figured out effectively is the fact that if the three numbers are of the form A minus D, A, and A plus D, then if the sum is S and the product is P, then A happens to be S by 3, and D happens to be root S squared by 9 minus 3P by S. Okay, so that gives us A and D. And once we have A and D, these two values, then we can figure out the middle term. Well, middle term is just known by this expression. And A plus D and A minus D can be figured out by knowing A and D. So we would also know these two quite easily. All right, so an example of this would be something like if you just take values of, say we have three numbers, and the first number is, and the sum of the number is S, is minus 3. So if say S is minus 3, and the product here is say 8. Okay, so if this is an example, so if this is the case, then we know that A equals S by 3, and that gives you minus 3 by 3. Sorry, that's plus 3, and that gives you negative 1. Okay, similarly, what we can do is we can say, okay, well, D in that case would be equal to root of S squared by 9. And what is S squared? Well, S is minus 3, so S squared is minus 3 squared, which is 9, divided by 9. And we have 3, and what is P? Well, P is 8. And what is S? Well, S is minus 3. Okay, so you do the math, this gives you, well, minus 1, and minus 1 changes this to 1. This gives you 1, so you're left with root of 1 plus 8, which gives you root of 9, which gives you plus minus 3. Remember, there are always two roots for a square root. So this gives you two values of D. What does that mean? So that case, if D is plus 3, and A, as we have found out, is minus 1, then the numbers are of the form A minus D. Well, the numbers are always of the form A minus D, A, and A plus D, right? So the first number would be Well, the first number would be, in that case, a minus d. So what's minus 1 minus 3? That's minus 4. What is the middle term? Well, that was just a, so that is minus 1. And what is the next term? That would be a plus d. So we have minus 1 plus 3, that gives you 2, right? And if we had a situation in which if d was minus 3 and a was minus 1, then what would have happened is that our sequence would have just reversed. So you do the math, a minus d is minus 1 minus 3, that gives you 2. The middle term remains the middle term, which is minus 1, and this term becomes minus 4. So it's as though we get two answers for two different APs. And the thing is, both these APs have the sum as minus 3. You add them up, it's minus 3, and the product is 8. Now, because taking a product or multiplication and addition or summation are associative properties, in the nature that the order in which they are multiplied or added doesn't matter. Therefore, the order in which we express the AP doesn't matter. Okay, so if you're just given these two properties, the order in which the AP comes about doesn't matter as long as the terms are evaluated. The only difference will come about for two different values of d is the fact that the AP is either descending, as is in this case, or is ascending. So the number becomes bigger and bigger in the first case when the difference is positive, as it should be the case because the numbers keep on increasing. Or if the difference is negative, then the numbers keep on decreasing. So that happens to be the other case. But it's the same thing that we're just considering the AP from the reverse order, which is simply fine. Okay, so that's the only difference that this makes. So this is just one way in which we could have taken our set of numbers. All right, so we could have chosen the central number to be a, and then we could have subtracted d and added d, and we could have gotten this this AP. Now, let's move on from 3 numbers to, say, 4 numbers. Okay, so we do the same thing, but in that case we have to be a bit more clever, in the sense that we would have to consider 4 terms rather than 3 terms. Okay, so in this case, what we're going to do is we're going to take 4 numbers in an AP, and we're going to say that, okay, the sum of their numbers is s, and the sum of the squares is, say, p. Okay, so what we have by that is we need to choose numbers such that their sum becomes a function of just one variable. So our numbers have to be a function of 2 variables, initial starting number and the common difference. In this case, the choice of variables becomes a minus d, a plus d, and basically these are the 2 numbers in an AP, and we can extend it infinitely in either directions. Now, the thing here is that in choosing these 2 numbers as consecutive numbers in the AP, the common difference becomes 2 times d. Okay, and you notice why that happens is because if you subtract this number from this number, the minus d adds up, and then the difference becomes 2d. Now, with that trend set, what we can do is we can predict what the next number is going to be. So that would just be this number plus the common difference. And that would be a plus d, which is the number itself, plus 2d. So that gives us a plus 3d. Similarly, here we can have a minus 3d. Okay, so that is the only difference we make from the case we started before, in which we have 3 numbers, and the choice of our numbers were a minus d, a, and a plus d. And the difference there was the common difference here is d, but the common difference here is 2 times d. So that is just a choice of variables we're making. Now, we do the same thing. The relations, they will always give you 2 relations because those 2 relations are required to solve two variables. Okay, so in this case, since the sum is the sum of all the numbers, then if we add a minus 3d, a plus 3d, we get 2a because the 3d's cancel out. And similarly, the minus d and the minus d cancel out, you're left with 2a as well. So the 2a's and the 2a's add up, and you get 4a. Therefore, the a, or just one variable in this case, will therefore be s by 4, the sum by 4. Now, for the sum, so that's the first relation, and now for the sum of the squares, what we can do is we can simply take the square. So that's a minus 3d square added to a minus d square added to a plus d square, and that can be added to a plus 3d square. And that is given as p. Now, this is not the product. This is the sum of squares, all right? So I'm just calling it p just for convenience. You now note that a plus b, so the formula for sum of squares is the following. So it's a square plus b square plus minus 2ab. So if it's a negative, we take the negative, and if it's the positive here, then we expand it as a positive. So note, if you expand all of them together, you have a negative 2 times a times 3d here that pops up, and here you have a plus 2 times a times 3d right there, okay? So these two numbers have to cancel out because they're just negatives of each other. And similarly, minus 2ad from here and plus 2ad from here will have to cancel out. What you're left with, so you've cancelled out these terms in this sum. What you're left with is a sum of individual squares. So by making this choice, the sum of the squares essentially becomes a square plus 9d square from this. Then you have a square plus d square from this. And then you have a square plus d square from this, and a square plus 3d whole square or 9d square from this. That equals p. Now do the math. You have 4a squares, so you get 4a square. You'll count the d's together. So you have 9 and then 1, so that makes 10. Then 1 makes 11 and 1 makes 20. So you have 20d square equals p. Now this is very simple to solve. All you have to do is solve for d. So 20d square equals p minus 4a square. And what's a square? Well, if s by 4 is a, then a square is s by 16. And therefore, if you multiply 4 on both sides, you get 4 in the denominator. So 4a square therefore just becomes s by 4. Well, s squared by 4, okay? So s squared divided by 4. Now, all you're left to do is to find the value for d, and that becomes root of, let me change the color, so root of 1 by 20 times p minus s squared divided by 4. So that's it. That's all that you have to do. Now you figured out what a is, and you figured out what d is as a function of p and s. And in order to figure out the terms in the AP, all you have to do is use these two formulae to get a minus d, a plus d, and a minus 3d, and a minus a plus 3d. Okay, so that's all that you have to do. So this makes it very easy. Just by the choice of the numbers that appear in the AP, we can actually simplify at least the sum relation. So the sum of them can be made a function of only one variable, as was the case here, and that variable was a. So the choice of numbers matters. It helps you with the mathematics, and that's just a clever trick people use when they deal with APs and problems on APs. Okay, hope this video made sense, and I hope it helped you, and all the very best.